Okay, so like I said, we're running out of sunlight here, so I'll do this quick. Now, the Moenave Formation south of here in St. George is thicker than here. And when you get down to northern Arizona, it gets quite a bit thicker. But it's not all that thick anywhere, but it is very important because it is the unit that has lots of dinosaur footprints in it. Right here, if there's any at all, it's right in here, and it's not very thick. It's probably right through here. So there's Chinle, and there's a couple of things above the Chinle, probably a little petrified forest, a little bit of owl rock, and then you grade right into the Moenave, and the Moenave represents lake sediments from Lake Dixie. And Lake Dixie was about 198 to about 195 million years ago, and it was a freshwater lake, and it came up to about Cedar City, about right here. Car going by. So it came up to about here, the lake did, at its further northernmost extent. And it extended out into Nevada, a ways, westward into Nevada, and eastward into Utah, but not very far. And it went down south into northern Arizona. And as far as like, Tuba City, almost Flagstaff it went to. So this is about 200 million years ago. And it was around for 3 or 4 million years, and there's lots of dinosaurs around there. It is famous in St. George for dinosaur footprints. So that's it right there. It's not a major unit here. All right, now above that is the Kayenta sandstone. So the Kayenta sandstone is about 193 million years old. So there was an unconformity right above the Moenave, so there is no deposition then. And then a couple million years later, there was deposition of what we call the Kayenta right there. And the Kayenta represents like aeolian dunes, meaning wind-blown dunes, sand dunes. It's not very thick right here. It's about right here or so, and it grades right into the Navajo sandstone, the big boy here. Navajo is huge in southern Utah. So Navajo sandstone is another aeolian or a dune sandstone. Basically, they're petrified or frozen dunes. You could think of them like that. Not really frozen. They're rock locked. They're locked up dunes, and you can see cross beds all over them. And there's lots of evidence of wind moving the particles around. So, that represents a time when there was a desert here. It was a huge desert. All that stuff right up there represents that, all the way up to the top of that ridge. So it's resistant to erosion, as you can see. It's sticking up. It makes cliffs and peaks like this. And some important features of the Navajo sandstone are it makes up most of the walls of Zion National Park. So when you go to Zion, that's what you're looking at right there, that stuff right there. Navajo was a very extensive unit. It covered all this area, all the way across Utah. But when you extend it down into Nevada, the Navajo sandstone is named the Aztec sandstone, but it's the same unit. And up in Wyoming, it's known as the Nugget sandstone, same unit. Also goes down into northern Arizona a ways. So it was very extensive. And it was deposited from about 190 to about 180 million years ago. So we would say early to middle Jurassic. And at this point, there were more dinosaurs. They had evolved more. So from this point to that point, they had evolved quite a bit.